Well, good morning, everyone, and welcome to today's Exploring by the Seat of Your Pants event. My name is Joe Grabowski, and I'll be your host for today. Here we are. We are 2 days away from Christmas holidays, the end of the 2025 school year. And believe it or not, we're not done yet. We still have a live event today for classrooms, and we've got 2 more coming up tomorrow. We're going to meet someone named Jason, who's going to talk about the really cool work that he's doing in fresh waters. And then we are also going to go to Antarctica to catch up with Sarah, who we've met up with a couple times this month as she's there on expedition doing some really cool science. So there are still more classroom events happening before the holidays. So we hope to see your classrooms joining us maybe 1 or 2 more times before the break. This will be my last event I'm hosting before the break, and I'm really excited that it is going to be a pretty exciting one. We have lots of classrooms joining us from Canada and the US across North America. Don't be shy to use the chat sidebar and send us in some questions and let us know where you're tuning in from. And today we're going to spend a little time with astronaut Jessica Meir. So she was selected in 2013 as one of an 8-member NASA astronaut class. Her first trip to space was in September 2019 through April 2020, expeditions 61 and 62. During this time, she was part of the first all-women spacewalk. So there were 3 of them in total. She spent 205 days in space, over 3,000 orbits of the Earth, which is a trip of over 85 million miles. That's wild. Along with her crew, she contributed to hundreds of experiments in biology, earth science, human research, physical sciences, and development of new technologies. So I am going to reach backstage and see if we have Jessica hanging out with us. Here we go. Hey, Jessica, how are you?
Hello, I'm doing well. Good to see you.
All right. Well, it is great to see you right before the holidays. Thanks so much for letting us steal a little bit of time.
Absolutely. I'm happy to be here with everybody.
All right. Very cool. Well, I'm going to give a shout out as well to Heidi working behind the scenes. She's going to help us with some of the screen sharing and other cool camera stuff. We couldn't do it without her. So Heidi, thank you for your help setting up today's event. I've got classrooms in the chat already saying hi. So I'm going to say hi to a few of them. South Carolina, some 4th graders, 3rd graders in Texas, 2nd and 3rd graders in Ontario, Canada. Where else? The Rise Institute, 7th graders in Maryland. So that's great. And then let's get things a little bit loud here for a second. I want to bring in some classrooms hanging out backstage. How's everyone doing today? You guys excited for a little hangout with Jessica? Excellent. So I'm going to tuck our groups backstage and we are going to get going. So Jessica, we're going to let you present for a little bit. We're going to have a Kahoot quiz. So classrooms, you might want to get ready for that. We're going to have tons of Q&A action. We're going to pack a lot into our time together. I'm really excited.
All right. Well, with that, I'm going to show you a few slides today just to talk about my particular path to becoming an astronaut. And then I'm going to show you a video that NASA put together that shows some of the highlights of living and working aboard the International Space Station. I grew up here, and I'm glad there are a lot of Canadian and American audiences because I grew up here right on the border between the US and Canada in northern Maine, in a town called Caribou. And from the time that I was 5 years old, my mother tells me I started saying I wanted to be an astronaut, and I never said anything else since. I was interested in biology. Even from the time that I was a little kid, biology was my favorite subject. I grew up in this small town with lots of trees around. I loved to be outside and explore and see nature and understand more about the world around me. I think my mother really instilled that in me, being a Swede and having this close connection to nature. And for me, I think this passion for biology also fueled this curiosity about the world around me and for exploration in general. And so I sort of pursued both of these paths of biology and also my interest in space all throughout the time that I was growing up, going to space camp even when I was in high school. And then in 1999, when I was graduating from Brown University with my undergraduate degree in biology, I had my first experience in microgravity. NASA has an airplane that flies in parabolas. So basically, the pilot shuts off the engine at the top and you are in free fall back to Earth for about 30-35 seconds. And that is microgravity. So it feels the same that we experience when we're actually in space, except it's very short-lived, only about 30-35 seconds before the pilot has to turn the engines back on. And then we experience 2 times the force of gravity. We designed an experiment comparing stitching, normal suturing if you had a cut and you had to go get stitches at the hospital, to using what were pretty new at the time, these tissue adhesives, so kind of like super glue that you would use to close a wound instead. So I'm going to talk today about these kind of big transition points in my life, and this was one of them. This was from when I went to being a student scientist all through my undergraduate studies at Brown University, and for example, ending with this, what we call the vomit comet flight, and then becoming a science coordinator. So after I graduated from Brown, I actually first went to France and did a master's degree in space studies. So everything about space, not just biology and physiology, but also orbital mechanics and engineering and policy and law, really everything about space. And then I came actually right here to the NASA Johnson Space Center, and I worked for 3 years as a scientist, as a science coordinator. So here is a picture of me training a Spanish astronaut, Pedro Duque, how to use the ultrasound that was going to be aboard the International Space Station. So I had an incredible 3 years here at NASA, serving as a scientist and supporting those astronauts that were flying. I also had an incredible opportunity to live underwater with 2 astronauts, a flight director, and some habitat technicians. This was kind of an analog to spaceflight, because if you think about it, how do we recreate space to train for everything that we need to do up there? We can't recreate everything here on Earth, so we try to find some environments that have some things in common. For example, if you're living in a habitat underwater, you need a life support system to go outside. You need scuba gear to go outside, just like you would in space, you would need a spacesuit. So there are a lot of parallels there. And I had a lot of those really incredible opportunities while I was working here as a scientist. But after 3 years, I thought, I really am still curious so much about the world around me, and I want to do my own science. I want to do my own experiments. And it went back to this fascination with biology, and I was particularly interested in animals and the incredible things that animals could do. So I decided to go back to school to get my PhD, and I decided to study diving physiology. I had seen these incredible accounts of emperor penguins that could dive in the Antarctic and hold their breath for 30 minutes, or elephant seals that could dive and hold their breath for almost 2 hours. And these are animals, air-breathing, breath-hold divers, just like you and me. I have to hold my breath to go underwater, so do they. But they can do it for a much, much longer period of time than we as humans can. So we were curious. We wanted to study these animals to understand how they could do it, what was unique about their bodies that enabled this kind of behavior. So I was lucky enough to go to the Antarctic. Sounds like you guys will have the opportunity to tune into some Antarctic researchers as well this weekend, I think, as Joe mentioned, so that's pretty exciting. I can tell you that the Antarctic is one of my favorite places on Earth, if not the best place on Earth. It is phenomenal, and I was very lucky to be down there for my work with emperor penguins. We were, as I mentioned, trying to understand more about their diving physiology. How can they stay underwater for so long and dive so deep? So we would actually put these little backpack recorders on the animals before they would dive, and then we would let them dive freely from these holes, and then we could collect all of the data with these recorders. So we could measure how deep they were diving. We could understand more about their physiology because we put heart rate electrodes on them, and even instruments that would measure the levels of oxygen in their blood. And I was actually lucky enough to dive down there with them as well, as you can see. We did these same sort of experiments on elephant seals as well. And as I mentioned, elephant seals can hold their breath even longer, 2 hours on a single breath. These experiments were done off the coast of California, and we would put the same kind of instruments on these animals and release them into the wild to dive back. We could do the same, get the same kind of measurements where we would see how they were diving, how long, how deep, and then also what was happening with their bodies, with their hearts, with the levels of oxygen in their bodies at the time. Then for my postdoctoral work, after I finished my PhD, I was interested in another animal, and this is the bar-headed goose. This is the bird that actually migrates twice a year over the tallest mountains on the planet. So now in this case, they're not diving underwater, so they're not holding their breath, but they are flying at very, very, very high altitudes. And at high altitudes, there isn't as much oxygen as we have in the air when we're here at sea level. And so it's still a very challenging situation for them, not like holding your breath, but dealing with lower oxygen in a different way. So for this experiment, I actually raised 12 goslings, bar-headed goslings. I was the first thing that they saw when they hatched, and so they became imprinted on me. Birds, waterfowl like goose, geese, and ducks have a very strong, what we call imprinting instinct. The first thing that they see, they think is their parent. So even though I wasn't actually another goose, these little baby geese, when they hatched in my hand, they thought that I was their mother. So as you can see here, they would follow me everywhere I went, and they would cuddle with me, and they really thought that I was their parent. This made them very comfortable with me, so we could start training them for the different things that we wanted to do with our experiments. The first thing was to get them ready to fly, because we were really interested, of course, in their bodies during the flight. So here you can see me on a motor scooter that I borrowed from another professor in the department, and I would drive up and down the road, and these birds would be flying next to me because they were my babies. They didn't want to be left behind. So they would take off and they would be flying next to me, and sometimes their wingtips would be brushing my arm. They would be so close to me. The idea here was to train them to fly in a wind tunnel. So if you've ever been on a treadmill or seen somebody on a treadmill, you're kind of walking or running in place. For them, a wind tunnel is pretty much the same thing. They're flying in place because they have this powerful wind blowing at them. So if we do these experiments in a wind tunnel, then we can put other instruments on them. So we had the same kind of instruments that we had on the geese or the seals, measuring things like heart rate and oxygen levels in their bodies. And you can see this goose is actually wearing a mask as well. And that mask is actually delivering nitrogen that they're breathing in. And that is creating this high altitude-like environment, lower oxygen environment, equivalent to about either 5,500 meters. So, well, a good portion of the way up in the Himalayas, or even down to 7% oxygen, which would be even higher than the summit of Mount Everest. So again, we were measuring these different aspects of these animals' bodies so that we can understand how they can accomplish the things that they do in the wild. So I look at this as now my last major transition that I'll talk about today. And this is from now going to doing my own science on these animals to becoming a subject myself. And I feel like this is kind of full circle for me because first I started out coordinating other people's science. Then I moved on to doing my own science with different animals as subjects. And now as an astronaut on my mission on the International Space Station, I was the subject, the one being poked and prodded in the name of science. So it really felt like it's kind of me paying my dues now from everything that I had done in my previous career. When we are on board the International Space Station, we do a wide variety of experiments ranging from all different types of sciences, cell biology, combustion science, materials science, physics, chemistry, molecular biology, and the physiology and medical experiments that really that I'm interested in the most because of my background. So you can see in that previous photo, that was me doing a blood draw. We take blood samples and things like urine samples so that we can analyze different things about our bodies. And here, I'm all instrumented for an experiment called cerebral autoregulation, which was looking at how the blood flow changes to the brain in space. Because of course, when we're in space, everything's weightless, including everything in our body. So we have this upward fluid shift of our blood, and it changes the way our blood circulates throughout the body. You can see, if you remember one of these earlier slides when I was training Pedro Duque how to use the ultrasound, I also did a lot of experiments during my mission using an ultrasound as well. This was an example of an experiment that was looking at the blood vessels in the human body. And in space, we have found that some of the walls of the blood vessels actually get much thicker and stiffer in spaceflight, equivalent to about 10 to 20 years of aging down here on Earth, even in just a 6-month mission. So we really wanted to understand why these things were happening. And that's why we do these types of experiments. So that's just a few examples about my particular path as a physiologist and scientist. And now I wanted to show you a little bit more using some video about what it is like to live and work on board the International Space Station. Just after sunset, so it was quite a thrill for everybody that was working this weekend. The view of the rocket, and that's actually a view from the International Space Station of our capital.
I can see a roll angle here.
And here's our view.
113 is the closing rate. I confirm the contact.
Astronaut Jessica Meir making her first flight to the station.
You can see that I was pretty excited. I was smiling that big pretty much the entire time.
Coming in through the hatch and seeing all these familiar faces feels like home already. It's going to be an amazing 6 months.
Of course, the best part about living in space is being weightless all the time. You can spin around in circles or take off down the module like Superman. I was preparing a charcuterie board here. I was fortunate enough to get some keys sent up to me, but most of the food that we eat is either dehydrated and just add water to warm it back up, or just put it in a food warmer. A lot more fun to play with your food in space, and even water, that's just water, because without gravity, everything's a lot more fun. Exercise is a very important part of our day up there, because without it, our muscles and bones will really decrease significantly without gravity. So we have a weightlifting machine that you saw, then we have a running treadmill, and then also a cycle odometer, like a stationary bike. Even brushing your teeth, of course, is a lot more fun in space. We were up there for a few holidays and commemorative Apollo anniversary, so we wanted to get the heart. And here is the ground for the holidays. But of course, the main point of being up there is for science. We conducted experiments of all different types, from combustion science, without gravity, or without gravity. Here we're loading some small satellites into the Japanese airlock because we'll be launching the orbit from the space station. We grew lettuce during my mission, which was really rewarding for me who loved plants and biology and had this green living thing growing that we watered and took care of. This is a glove box where we do cellular biology type experiments, all different types of life science experiments. This was a physiology experiment where we were looking at all the different aspects of that upward fluid shift that we spoke about. And this is our freezer, so we've got to keep samples frozen throughout the mission. We put them in here. And we did a lot of spacewalks during my mission. In 4 months, we did 9 spacewalks. So we were very, very busy doing spacewalks, but we didn't complain because we were really excited to do it.
Jessica, Christina, we are so proud of you. You're going to do great today. We'll be waiting for you here in a couple hours when you get home. Have a great, great EVA.
Drew, thank you so much. Thank you, Drew. Thank you so much.
That's Italian astronaut who's flying the arm at Christina's Lockheed. And we were out there to upgrade some batteries on the space station to some newer lithium-ion technologies. Spacewalks are the risky and most challenging thing to do, but it's really different to look down just through your thin eyes. How do we get everything we need on the ground in space? We have some different types of vehicles that arrive in space, and we reach over and grab them with the robotic arm that we make with the stages, and then unload all the different cargo that comes in. Clothes that we deliver on board the space station. Sometimes we get fresh fruits and vegetables delivered, which is exciting. Get this run to the grocery store, of course. And at the end, we actually pack these vehicles full of our trash, and they actually burn up in the atmosphere. With the exception of the SpaceX Dragon, if you have samples of things that need to return back to the Earth, that one splashes down in the ocean and is recovered. What are we doing when we're not doing science? Usually you can find at least one person looking out the window because the view that we have is so special and so beautiful. And we also take a lot of photographs from these windows because scientists can actually use our photos as well. We pass over the same sites again and again and again so we can monitor things over time like the retreat of glaciers. It never gets old to look out of the window from the space station. Even when you pass over the same spot, it always looks different because of different lighting, different cloud cover. That's the coast of Israel coming over the Middle East. Sunrises and sunsets, we see 16 of those every day. We're going around the planet every 90 minutes. Those are lightning flashes, and you can see the city lights at night. This is the Nile River. You can see all the lights on the Nile River exploding into Cairo. These are squid fishing boats off the coast of Thailand. These are the northern lights. You see the northern and the southern lights, and they are incredibly beautiful to see. Unfortunately, the 205 days that I was up there for went by way too fast. I was not ready to go home. I would have rather stayed home. But it was time for us to leave, so we were getting back in our vehicle, saying goodbye to our friends. Ready to go home. It's a very dynamic ride. We're undocking from the space station, and as we re-enter through the atmosphere, I can see through my left window that the capsule is literally burning up in the atmosphere. Luckily, we are protected by our heat shield. We land in the middle of nowhere in Kazakhstan, and the Russian search and rescue forces are there very quickly to pick us up. For me, that was a very strange time because we lived in April of 2020, so we're in the middle of COVID, things were really bad. We launched, we didn't know what COVID was, and saw it all happening in the space station, so it was very strange that we came back to a completely different planet.
All right.
The one thing I just wanted to end on was talking about finding your own path and your own passion. You know, I talked a lot about my individual path, my interest in biology, and my interest in space. But for the important message to remember is that it's really important to identify your passion, to find the one thing that you're passionate about and really explore that and push for that, because I truly believe if you're not doing what you love, then you're probably not going to be able to excel at it, and you probably won't be happy doing it either. So identify that passion. And a couple other lessons. Remember that it's okay to fail along the way. You should you need to take risks in order to achieve these great things. And sometimes it's scary to push yourself, to go outside the envelope a little bit and to take a risk. But without those risks, I don't think that you get the truly great rewards. So be willing to take a risk. Know that you'll fail along the way, because when we fail, that's when we learn the most important lessons. That was that slide. So with that, I think that we'll just move over to questions.
All right, sounds good to me. Jessica, thank you for that great presentation. I think what I like is that it highlights different routes to becoming an astronaut. I think you had a very cool route along the way, and yeah, it led you to your passion and what you wanted to do. So before we get into Q&A action, I am going to change gears, and we are going to have a Kahoot quiz together with the classrooms. We have so many classrooms hanging out today that I think it would be fun if we play some Kahoot. So I am going to share my screen, and we'll get that up there front and center. Now, if you want to join in with us today, you can do it in a few different ways. If you have a Chromebook or a tablet right at your desk, you can go to kahoot.it. You can join right at your seat. If you don't have something at your seat, well, this is already up at the front of your room, so you can shout out your answers to your teacher and see how your class does. If you're joining from home, you can scan the QR code with a phone, with a tablet, and it will bring you in. But while we wait for students to join us, and I can see we've got a big group coming in already, I'm going to take a few questions from the YouTube chat. So we're going to get started with a few questions. Jessica, did you have any fear about leaving Earth, and how did you overcome it if you did?
No, I don't remember really being afraid or having any fear. And I think that the reason for that is because we have so much training. We have years of training on the ground, so we really understand everything that we're doing. And we've done it a million times before here on the ground in simulators. And so that gives us the confidence that we need. We trust in our hardware and our equipment. And I think most importantly, we trust in our team. We have hundreds and thousands of people on the ground that have built these rockets, that are monitoring everything and watching out for all of the things along the way. So I think that actually prevents us, from being afraid.
All right. Another question here from a classroom is, being in space, what did that feel like? How did you adjust?
It feels amazing. And I've said this a lot of times before, but it's really true. It was even more incredible than I ever imagined. And I had been dreaming about it since I was 5 years old. You never know. Sometimes when you're waiting for something, or you have something up high on this pedestal, you never know if it will actually be as great as you think it might be. But space absolutely was. It was no letdown. From the very first moment you experience weightlessness, which is only about 9 minutes after takeoff, everything kind of starts lifting up. Everything's floating. All the little things that are on the bottom of the capsule even start rising up. The pencil in front of you starts floating up. And you kind of feel like you're at the playground hanging upside down from the monkey bars, because all the blood rushes to your head. And that feeling never really goes away the whole time. Your body adjusts to it. But yeah, it's very unique, and it's just so much fun to be floating around all the time.
All right, let's squeeze in one more before we start the Kahoot. Elena in grade 2 would like to know, can you tell us about another experiment that you did while you were in space?
Let's see, another experiment that I did. We did some experiments. We talked about some of the physiology ones and growing the lettuce. We also did some experiments with mice, just like we do here on the ground, to understand other aspects about biology and physiology and medicine. And there's an experiment called Mighty Mice, where there were these mice that had a different genetic makeup, and they basically were missing this one gene that is very relevant to the breakdown of muscle in the normal body. Humans have the same gene as well. And so these mice, they were like mighty mice. They were like the Arnold Schwarzenegger of the mouse world, with these really, really big, beefy muscles. And so that was a really important experiment, because it teaches us a lot about muscle preservation and bone quality preservation here on Earth for lots of different types of diseases that have problems with those systems. And also it could be very important for the future of human spaceflight, when you saw those really large pieces of exercise equipment that we had on the space station. When we go back to the moon and we go to Mars, we have much smaller spacecraft, so we won't be able to fit those really large pieces of exercise equipment. So we might need to use some other types of therapies to preserve our muscle mass.
All right. Well, we're going to get some faces in here shortly from our backstage classrooms, but we're going to play our Kahoot first. So as a reminder, you have 20 to 30 seconds, depending on if it's a multiple choice or a true or false. The quicker you put in the right answer, the more points you're going to get. So let's see how we do. So how many days did Jessica spend in space? Was it 100? Was it 173? Was it 205? Or was it 302? So this has come up a few times during the intro, during the video. How many days? 100, 173, 205, or 302? Got a few more seconds. All right, good job, crew. 205 days. Let's take a look. The knowing mantis is in first spot on that scoreboard. We've got a true or false coming your way. Elephant seals can hold their breath for up to 2 hours. Do we know Jessica spent time in Antarctica? We know she was hanging out with those diving penguins and the elephant seals, but is it true that they can hold their breath for up to 2 hours? True or false? 6 seconds left to lock something in. And we'll see. Oh no, I got the wrong one in here. It is not false. It is absolutely true. So shout out to all the classrooms who put true. I made it too fast in the background, but it is absolutely true. Good job, students. All right. So let's go to our next one. True or false? Experiments in space take place in the same gravity as Earth. Is that true or is that false? So the experiments in space, they're taking place in the same gravity as on Earth. Is that true? Is that false? That experiments in space are in the same gravity. You have 5 more seconds. We'll hope I clicked the right true or false for this one. We're about to find out. Oh, good. I got it right. It is false. It's in microgravity, which is why it's such an interesting environment to do these different types of experiments. What did that do? The whimsical newt is in that top spot. Final question coming your way. So how many spacewalks took place on Jessica's missions? We're looking for the total number here of spacewalks on the mission. Was it 2? Was it 3? Was it 5? Or was it 9? You have 10 seconds to get it locked in. Was it 2 spacewalks in total, 3, 5, or 9 that took place over the duration of the mission? All right, a little spread out, but the right answer is 9. Most went with 9. Now, Jessica was part of, was it 3 of those in total for you, Jessica? I know there are 3 all female. Yep. All right. So let's take a look at our podium. In third place, we've got the radiant elephant. In our second spot, we've got the brave narwhal. And holding down that top spot, the golden shark. All right. Good job, crew. Thanks for playing along with us. I'm going to turn off the music, turn off the screen share, and it is now 100% Q&A time. So I'm going to bring up my handy page that has all of our classrooms who are backstage. And we are going to start off. Let's see, where should we go first? Let's start off with one of our homeschool groups. Let's go to Topsail, North Carolina. Let's get them in here front and center. Here we go.
Hi.
Hey, North Carolina crew, how we doing?
Awesome. How are you guys?
Good, good. Great to see you today.
It's great seeing you guys. So my first question was, what are some challenges that you may have run into while you're in space?
Well, I think the challenges are different for everybody, but I think one of the challenges when you're actually in space is being away from your loved ones, from your family members. And, you know, for me, at the time I wasn't married and I didn't have any children. So maybe that was one of the reasons why I wanted to stay longer. I wasn't even ready to come home. But I'm actually getting ready to go back to space. In 2 months, I'm going to be going back to the International Space Station. And this one will be the 8-month mission. And now I have a husband and also a baby. I have a 3-year-old. She'll be 3 in January. So I think that for me, the biggest challenge on this next mission will be to be away from my daughter.
Thank you for sharing that. We have another question, but I don't know if we're allowed to ask or we wait until next round, Joe.
I'm going to try to come back. I want to make sure we get at least one round in each group, and then I'll see what our timing looks like. But that was a great question to kick things off. We're going to go to some grade 6s. St. Gabriel grade 6s. Oh, it looks like they've got some astronauts there with them.
Do it.
Hi, it's a
Hey,
pleasure
how's
to
it going?
meet you. Good, how are you?
Good.
Okay, my name is Ava and I have a question. My question is, how is bacteria different from space and then on Earth?
So there have been some different experiments looking at bacterial growth in various systems. And I'm actually, I'd have to look at the results from those experiments because I don't know if there's a general answer. But it is definitely something that we've been studying here at NASA to understand. So we'll actually take different samples of the space station to make sure, because you know how bacteria can accumulate in your own home if you don't clean it well, on food and these kind of things. And so we want to make sure that we're still keeping the space station clean for us so that we don't get sick. So we'll actually swab and take different samples from around the space station and send those back to Earth to be analyzed. And now we have some newer technologies where we're hopefully able to test some of those, do more of that processing on the space station itself. One of the other really cool experiments that we have done once before and we're getting ready to do again is actually swabbing the outside of the space station when we're doing spacewalks to see if any bacteria or any other organisms are making their way outside or contaminating the outside of the space station as well. And so that will be really interesting to see those results.
All right.
Thank you.
Great question. So we will try to swing back. We might have time for a lightning round at the end. We'll see. Group 602 hanging out with us. Is this our group in Quebec?
Yes, it is.
Yeah. How's everyone doing?
Good, thank you.
Good.
Question is, after returning back to Earth from a space mission, how do you what does it take to get used to have gravity again?
Yeah, well,
Because in space there's no gravity.
When I came back from my mission, I said many times, gravity is overrated because you really don't feel great when you come back. You feel very tired. You feel like somebody is pushing down on you, like a bully in a playground, pushing down on your head because you literally feel gravity. You're not used to that being in space for many, many months. So you feel tired. I had some lingering back pain. I felt pretty stiff when I was on the couch and I would get up. My back would be really stiff. I felt like I was 80 years old getting up off the couch. And so it takes your body a little bit of time to get used to it again. But we have some special trainers here in the gym, and they take a lot of good care of us to help us rehabilitate those systems and to get used to gravity again. So, actually within a few days, normally at first, in those very first hours, you're kind of like a drunken sailor. Your balance is kind of all off at first, but then you get used to that. Running takes a little bit longer. And then we have some of these things that linger for a few months, like the back pain. Overall, it doesn't feel great, but you get used to it again.
Thank you.
All right. Let's grab some Texans in here. Mrs. Paget's class, how are we doing today? All right, let's grab the mic too. Yep, perfect.
My name is Jordan, and I have a question. Is the spacewalk scary?
People have very different reactions to it. Some people do feel a bit scared. They feel like they're falling. I actually didn't feel that way. I just felt excited. But when you look down at your feet, it is quite strange because you come out of the hatch for the first time, you look down and you see your feet, and then there's nothing else but the Earth about 250 miles below. So it's pretty crazy. Some people kind of feel like they're falling. But it's pretty variable on how people feel. And I think it doesn't, for all of the astronauts that do spacewalks, we have so much training that even if they're scared at first, that training kicks in and they're still able to do the spacewalk safely and successfully, and even to have a little bit of fun as well and enjoy the view.
All right, great question, crew. Let's go to our second homeschool group hanging out with us. How are we doing today?
Ask you.
Do you think humans will ever live on the moon or Mars?
I hope so. You know, right now at NASA, we have a program called Artemis, and we're getting ready to launch the first crew to go back to the moon. They'll hopefully be launching in February or soon after. And that first mission will actually just go around the moon. It'll be about a 10-day mission, and they'll stay in orbit and come back. But the later missions will actually land on the moon. We haven't been back to the moon since the 60s and 70s, so it's really exciting that we'll be going back there. Eventually, you know, maybe there will be colonies on the moon or even on other planets like Mars. I don't think that's in our immediate plan right now. We need to first get back there and demonstrate that we can do it. But maybe by the time that you are an astronaut, if you want to be one, or some of your peers are astronauts, maybe by then we will have colonies on the moon or Mars. It's certainly something that people are thinking about.
All right, great question. Okay, Miss Brigham's crew, I'm going to bring you in. How you doing, Mrs. Brigham?
We're doing well. One of our questions was, how do you sleep when you're in space?
Yeah, I actually slept really well, and most people do. We have a small area called our personal crew quarters. It's about the size of a phone booth. If people, maybe the teachers know what that means, the kids probably don't. We have a sleeping bag on the wall of our crew quarters. So that's attached to the wall so that we can, you know, get into our sleeping bag and kind of stay in place. So we're not just kind of free floating all over, because then you might kind of wake yourself up in the middle of the night. So most people will get into their sleeping bag. Some people will strap their arms down. And I kind of would like wedge my head into the corner so you kind of feel like you're in contact with something like you would here on Earth. But I slept really well, and I think a lot of people do, because you don't wake up in the middle of the night with a sore knee or a sore back or a sore neck like a lot of us do, especially as we get older. And so, yeah, it was a lot of fun to sleep in space.
Awesome. Thank you.
All right, thank you. Mrs. Bullock's class, we've got you here. Hey, everybody.
How do you know if you're going to land in the ocean?
Well, when we come back to Earth, it depends on the spacecraft that you are flying. So the Soyuz spacecraft, like you saw in that video, it's designed to land on land. So we carefully control what we call our deorbit burn. So we give a propulsive force with the engines on our rocket so that we enter the atmosphere where we want to, and that will predict where we land, whether we want to land on land or in the ocean. So the Soyuz always wants to land on land because that's how it's designed. But on my next mission, I'll be flying on the SpaceX Dragon, and that vehicle is designed to land in the water. So that it's the same kind of thing where you have parachutes to slow it down as it's coming down. But with SpaceX, we will be landing in the ocean.
Thank you.
All right, very cool. So I need to work in this question because we have some grade 7s from Manitoba, and they were really excited to join today, but they had a blizzard. So they're all at home today, but their teacher sent me in some questions. And the one that I want to work in is they want to know, when you got on the space station and you looked back at Earth for the first time, what did that feel like?
It's really incredible, and I can tell you that it's as incredible even on the last time I looked down from the window after 205 days. As I talked about during the video, the view always looks different. First of all, it's breathtakingly beautiful because of the color palette and the clouds and the atmosphere all among the void blackness of space. And you see this very thin, tenuous band of an atmosphere, and that's really all that's protecting all of the life on Earth. The colors and the textures are so incredibly gorgeous. And it really makes you remember how special and unique the Earth is, and really how we have to take care of it. We don't have another Earth. We don't have a backup plan. So we need to make sure that we protect our environment, that we take care of the planet that we're on. And you can also see from when you look down from space how interconnected it is. All of the oceans and the land masses, and you understand that really we are all in this together. We are one human, all living together on this same home planet that we call Earth. And I think sometimes as humans, it's hard to remember that. We get distracted by other things in front of us and by politics and things that tend to separate us as individuals. And I think that it's very important to keep that larger perspective and realize that we are all one human and we're all in this together.
All right. Well, Jessica, I know that you are doing a lot of training right now, so I know your days are all organized and timed out. Do we have time for a quick lightning round? What's the timing looking like? It's okay if we're out of time.
Sure, we can do a quick one.
Okay, let's see what we can do. So let's go speed through. Mrs. Brigham, do you have a follow-up from your class? I'm going to put class on the spot. It's going to be a different order this time. We're going to get crazy.
I think you actually answered all of our questions that we had.
Okay.
Thank you.
No worries. Where's your class joining us from today, Miss Brigham?
We're from the Virtual Learning Academy, so we're all over New York State.
All right, very cool. Well, shout out to your crew. We're going to go through our homeschool classes right now, so we'll see if they have a follow-up for us.
Gotta unmute.
What?
There you go.
What food did you miss from Earth the most?
I missed fresh fruits and vegetables. You saw that we get those delivered sometimes on visiting vehicles, but on a daily basis, we don't really have them. That's why it was so exciting to have that lettuce that was growing.
Thank you.
All right. And then we'll go to Topsail.
Hi. So my other question was, seeing Earth from so far away, what have you learned about how we can take better care of our planet?
Well, like I was just talking about, I think it gives you this added appreciation for our planet. And for me, I was an avid environmentalist even before my mission, but I think that every astronaut comes back with that appreciation. And I think one thing to remember is, sometimes people think of, oh, maybe just I can't make a difference, I'm just one person. But if everybody says that, and if everybody tries to make a difference, whether it's trying to eliminate plastic bags, or trying to be more fuel efficient, or use an electric vehicle, or better yet, use public transportation or carpool, all these little things that you can do to try to help protect our planet really can make a difference if we all pitch in.
Thank you so much. Your
thank
talk was
you.
really inspiring, and we'll be rewatching it for sure.
Thank you.
Thank you.
All right, we're crushing this lightning round. Back to Ottawa.
How do you measure the size and the age of the universe?
That is a question that is far beyond my knowledge. I'm a biologist and physiologist, and I think we really need some astrophysicists to answer this question. Joe, maybe you can get an astrophysicist on this program to answer that one.
Yeah, well, we interviewed Brian Cox recently, Dr. Brian Cox. So if you want to check that out on the channel, he did a really fun interview with us where he talks a little bit about astrophysics and things like that. So you might want to check that out, and he might answer some of your questions on quantum physics and such. So that's a hard question. That's a big question.
All right, thanks.
All right, thank you. Back to Texas.
My name's Millie, and I was wondering how it feels when you're in the rocket launch.
It's very exciting, and it's interesting because we do so much training on the ground in simulators. So they look the same as the capsule. You still have all the same controls and displays. And so sometimes, you're just used to doing all of those motions. So I remember for me on my launch day, I had to remind myself that I was actually going to space, and that after 9 minutes, I would actually be in space, because everything looked exactly the same way. I was doing all the same things that I had done in the trainer. So for me, I was doing all the same things. I was very busy, and I had to remind myself that it was actually going to happen. But then as soon as we got into weightlessness and everything kind of started floating, it was just completely exhilarating and so exciting. And I remember looking over at Huzzah, the Russian commander that I flew with. He had been in space before, so it wasn't as new for him. But I looked over at Huzzah, and both of us were just like, his eyes were as big as saucers, and both of us were kind of jaw dropped, mouths open, just so excited to actually feel this prolonged weightlessness and be in space for the first time.
Thank you.
All right, thank you. Back to the U.S. one more time. All right,
Can y'all see the ring light of the atmosphere?
Yeah, you can see the atmosphere. And so maybe you could see it in some of the video and photos that I showed, where you see the whole, and then there's a thin band. You can kind of see through it, and you can see the end of it. And the interesting thing about it is that you can, here when you look at the sky, when you're in an airplane, it's a blue sky, but we don't see all the differences as the atmosphere gets thinner and thinner. But from space, when you see it, you can actually see that it's darker blue when it's close to Earth, and then it gets lighter and lighter and lighter and lighter and lighter as then it just, at the end of the atmosphere, it just turns into the blackness of space. So it's really interesting to see And at night, you can see this kind of air glow where you have kind of this thin orange band at the top of the atmosphere. Sometimes you can see the northern and southern lights like you saw in the video. So it is really cool to see.
All right. Thanks, crew. Final question for you, Jess. This one's from YouTube. You did multiple spacewalks. What's that suit like? Getting into that suit, moving in that suit. What's that suit like?
It's pretty difficult to work in. You weigh over 400 pounds when you're in it, and everything that you do is pressurized. So it's kind of like reacting against like one of those pressure balls that you squeeze. And we actually have one of the gloves here that you can see. You can see when I put this on, actually this glove's way too small for me to even put on, but it makes your hand very, very bulky. You can see how much bigger it is. And so that you kind of lose some of the dexterity that you have. So it's more difficult to work in, and you're reacting against that really high pressure. So just closing your hand can take a lot of effort. So it is difficult, like I mentioned, the most challenging thing that we do and the riskiest thing that we do, but it is absolutely the most rewarding thing that we do up there as well.
All right. Well, I want to start off with a huge shout out to all of our classrooms, our homeschool groups, our classrooms, our YouTube groups, our camera classrooms. Thank you so much for hanging out with us before the holidays. Jessica, thank you for taking time. I know you've got a crazy busy schedule. You got something kind of exciting coming up. So thank you for giving us some time. Thank you for those great questions and answers and the presentation. And good luck in the coming months. It's pretty exciting.
Okay, thank you everybody. Happy holidays, and be sure to tune in to our next mission.
Thank you.
Thank you for hanging out with us. And we are going to sign off for now. Have a great holiday, everybody.
Yeah.